Shocking. Okay, now, chapter 2.5, linear regression, step 1. Not completely. Graph the points. How do I graph those points? So tell me, Tristan, what would I do?
Go to, or start at point 0, 0, go to the left, two places, and up 5.
So to the left 2, up 5. Do we all see that? There's the points. Yes?
Yes.
How do I graph the point 3, negative 4? Someone else.
Right 3.
Trevor?
Right 3.
Right 3, down 4. Put me right there. Can we all graph points now? Yes or no?
Yes.
That's part of tonight's homework. Great. We're supposed to put on the calculator? Negative. Oh. Sit down. Where are you going? Okay. Now, that's what we are doing today is linear regression. So with linear regression, what this actually means, now you have another partner, because we have an odd number. Linear regression is a linear equation that gives an accurate model to do predictions of the future given a set of data. What does this mean? Well, what is going to happen around the country on Tuesday, November the 6th?
Trick or treat.
It is not trick or treat.
When is that?
What is it?
Wednesday.
Election day.
Oh.
It's election day. Election day is going to take place. And why is this year's election so important?
Presidential.
Because we are voting for a new president or now, keep your opinions to yourself. I'm not asking you about your political views, but I'm trying to get you to understand that the whole point of what happens is they collect data. Now, how many of you have been getting phone calls to your house asking for the person who legally can vote in your house if they can please answer a few questions? They're taking surveys. Those surveys collect data so that the candidates can then determine where the public stands on certain views, so they then can address those views and take certain stances. Agree?
Agreed.
Those stances are able to, that data that they get, they are then able to interpret that data to do a prediction of the future to determine who will be the next presidential candidate. Correct? If someone is at a 25% full rate, you think they're probably going to get elected president. Now, someone who is at 49 or 52%, what do you think? They have a strong possibility?
Yes.
It's possible. Okay, somebody who has an 80% on likable factor, chances are they're probably going to blow the election away and they're going to win. Do we get that?
Yes.
Okay? So everything we're talking about today, 100% happens in real life. Yes? So what we need to do is we need to come up with data, and we need to find a regression model that fits that data so that we can come up with a prediction in the future of what's going to happen. Now, I use the election as an example, but another one that we could be using before we go there, there's types of regression. We're talking about linear regression today. Linear regression means that you are talking about lines. Another type of regression would be quadratic regression, meaning it looks like a U. Okay? Exponential regression, it looks like this. Logarithmic is the opposite of that. Sinusoidal, meaning it is the heart rate. It is the sine curve. Okay, do we see that? And the last one is going to be logistics. It's used for earthquakes and things of that nature. And it looks like this. Do we see that? Yay or nay?
Yay.
Now, are we focusing on any of these today? The only one we're focusing on is going to be linear. Okay? Now, moving right along, we have a correlation. Now, a correlation helps us to determine if the actual regression model that we use is a good enough model to do predictions into the future. Well, how do we know if something is a good enough model to do predictions in the future? We have to look at the R value. Well, where does the R value come from, Mrs. Garrett? Well, I'm so glad you asked, Mrs. Garrett. Isn't that wonderful? I answer my own questions. Okay? You determine if something has a correlation based upon the R value. The calculator will give you your R value, and it is done after you find your regression model. The R value is given with the regression model. If you are listening to me like I'm Charlie Brown's teacher, so you need to snap out of it now and focus. I can name like 5 of them right now. So, the closer the R value is to the value 1, the more accurate the regression model will be. Well, do we want an accurate model if we're defeating the presidential candidates?
Yes.
Well, yeah, I do, because guess what? If I need to go to the state of Ohio, since we're a swing state, if I need to go there several times to make a stance to make them understand that I am for their issues, I need to make sure that I have a public appearance in there. Do we understand that? I need a very good set of data that shows that the people in the state of Ohio are uncertain of who they're going to vote for. If you go to a state that is 100% certain that they are probably going to vote for Obama or Romney, do those people need to attend that state? No, they need to spend their time and resources in the states that are uncertain. Do we understand why a good representation can be a very good idea here?
Yes.
Now, we have positive, negative correlations. A positive correlation is whenever you're going uphill. A negative correlation, when you're going downhill. Makes sense, right? A strong correlation is going to be when the resulting R value is extremely close to 1. In other words, it's going to be 0.98 to 0.99. That's going to be a strong regression model, okay? And then a weak correlation model is going to be whenever we have the values below 0.98. Now, I've given you some pictures on the next slide. That came straight from your textbook, that thing that many of you don't know where it's at, that you never opened. Yeah, it came from that in your textbook. Now, in order to determine if something has a strong or negative correlation, what this means is you need to make sure that you're drawing a line. If we're drawing a line, then that means I'm going to draw a line through this information. Okay? How many points did my line touch? Most of the points, meaning the points are all clustered on my line that I drew. That means it's a strong correlation because there's a lot of points touching my line. Make sense? A weak correlation means I can draw my line, but how many points is it touching now? 1. Well, 1 or 2, not very accurate, is it? It's a weak correlation because clearly the best correlation is whenever all the lines, the dots are on my line. Okay? And then the no correlation means that if I draw a line this way and that way, meaning positive and negative, that means I'm undecided. There's no correlation there because someone in here may say, well, that has a positive slope. Someone else here might say that has a negative slope. Well, if you can't decide, chances are it has no correlation. Do we understand that, yes or no?
Yes.
Is data like that helpful to an election?
Yes.
No, data like that is not helpful to election at all. When you have no correlation, that gives you no information, does it?
So you had all of them all together.
But a strong or a weak correlation would definitely help a presidential candidate out. Do we understand that?
Yeah.
Okay. Now, coming down here for weak and positive correlation, the same exact concept here. Can we see the difference between, wow, that was real bad. Can we see the difference between the weak and the strong correlations there when they're positive? Yes or no?
Yes.
Clearly, you can see this is only touching about 1 dot. Over here, this is touching at least 5 dots. Does that make sense? Tonight's homework is simply graphing ordered pairs, making a scatter plot, and telling you if it has a positive or negative correlation along with strong or weak. Do you think you can do that? That's all you got to do. You have 4 problems like that. It should take you no more than 15, 20 minutes. Okay, am I giving you that homework now? No, because half of you will not listen to anything I ask you to do from here on out. True. So with that said, here's where we need to really focus our time on today. Because this lesson is so intense on the calculator, I had to break this up many different times. So, what I want you guys to do is I want you to make sure that you have your calculators and that you are, please, looking at your partner's screen and making sure your screen matches my screen every time. Do we all understand what I just said? Okay? Now, with that said, I give you this problem. The problem says you researched the average cost of the whole milk for several recent years to look for a trend. What in the world? What's a trend?
Like a
rising or falling.
Similarity.
Yep.
Similarity, something, a trend is going to be something that makes, like take fashion trends. It's something that has been for a long time. And it has the same calculation for a long time, then all of a sudden it changes. That's a trend, right? Now, what would affect the trend of the cost of milk per gallon?
Not cows.
Cows. Well, milk comes from cows, right? So therefore, everything that affects the milk cost is going to deal with a cow. So what would deal with a cow that would make the cost of the milk go up?
Well, how it doesn't produce.
Cow doesn't produce much milk, but let's say all of our cows are healthy, and let's say we have fields of cows, which that has nothing to do with it. What else would affect it? How much the feed is, and what do cows eat? Grain or corn or hay or straw, all that, right? So with that said, could the weather, not straw, the weather throughout the year, especially in the summertime, whenever we are in corn season, can that affect the cost of the milk in the winter?
Yes.
Yes.
Why? What if we have a really bad corn season?
That's no milk.
The price of the feed goes up to feed the cows, which means that the price of the feed goes up. What do the farmers have to do then? They have to raise the milk prices because they have to then make sure that their expenses are covered. We all understand that here. So that's a trend. So the weather can affect that. Okay. Now let's talk about this a little bit. We have year 1998, and the average cost of a gallon was $2.65. Year 2000 was $2.89, and so on and so forth. Now, let's talk about graphing this. How do I make a scatter plot of this? What's going to be my y and my x-axis?
Your year would be your X.
Your year would be your x-axis.
Y would be your cost.
Your y would be your cost. Very good. Okay, well, where is the year 1998?
Closest to
Really?
closest.
Because if I have my units of increment 1,
Do this with
holy bejeebers, where's my year 1998?
Way up.
Way out there.
Right by the TV.
Probably way past.
line.
Let's do that little like.
Do the break.
Yeah. Like,
Okay, we're not going to do a break because what we're going to do is we're going to think about what we would do if we would scale things down. Okay? Have you ever, who in here is in CAD? I only have one person. Who is in, no, carpentry? Okay, any of the house building projects area, we have to read blueprints. Anybody's in any of those lines? HVAC, what? Industrial electricity, you gotta read blueprints. Have you ever seen an architect carry the blueprints around that were exactly the same size as the building that he built?
No.
Why? Not drawn to scale. Because if it is drawn to scale, then that means the piece of paper will be exactly the same size as the building itself. Who in their right mind is going to do that? It's not going to happen. So what do architects and engineers do? They scale it down, which means everything centers around what?
a ratio.
A ratio, more importantly, around the x and the y axis, which is starting at the origin, correct? They take the center of the project and they go out from there. Do we understand that?
Yes.
Okay, now with that said, let's think about this. I want to scale down the year 1998, which means I need to let 1998 represent a different number than what it actually is. So what we're going to do is we're going to let that be the year 8. Why? Because it ends in an 8. Totally legit. You could be 0 if you wanted to. Okay? We're going to end with what it is. Now, how many units is there between the year 1998 and the year 2000? 2. So I'm going to add 2 units to the year 8 to give me the year 10 to be the same thing as 2000. Yes? Add 2 more to give you 12, 14, 16, and 18. I would write that on your paper, y'all. I'm not here to just do it for you because I already know how to do it. Okay. Now, we are not going to make a scatter plot by hand. What we are going to do is we're going to use the calculator to make the scatter plot. Now, previously I gave you the lovely little regression steps, did I not? So I want you to get these regression steps out. We're going to go step by step through this so you can see on the graphic calculator how to do these things. Are we ready? Make sure your partner and you are working together and on the same page. So I'm going to come over here. And the first thing I need to do is step 1, entering in data. So what do I do with entering my data?
Make a new document.
Make a new document. So I'm going to hit 1 for new document. Make sure your partner's not lost, because if I have to come back and show them how to hit 1 for a new document, I'm going to say you're not a very good partner. Now, step 2, what do I do?
Choose list spreadsheet.
List and spreadsheet. How many people in here understand what Microsoft Excel looks like and have used it in the past? Microsoft Excel is going to be a spreadsheet document that allows you to add, subtract, multiply, and divide, and add formulas within a document. Okay? Now, that's exactly what we have in our calculator. Step 3 says to do what? Click on cell A. Well, gee, that sounds very self-explanatory. Go up and click on it. Step 4, what's that say to do? Well, what do my X values represent? A year, so type year. And hit enter. What's the next step say to do?
Click on cell B.
Click on cell B. Self-explanatory. Now what do I do with that?
Right. Cost.
That needs to be the cost, because that's what represents my lovely little Y values. Then I'll check your partner, make sure your partner has exactly what you have and what I have. If they're not, help them out. Okay. So now, what's step 8 say to do?
Click on column
What's
A.
step 7? What's step 7 say?
Do not enter data in the gray.
Do you guys see this gray shaded box right here? This gray shaded row? Do not enter anything in that, because that is the formula base. Okay. If you type anything in this gray row, it's going to automatically come up as a formula, and it's going to use that formula throughout the entire spreadsheet. You don't want that. So don't type anything in there. So the next step, on step number 8, I believe, it says to click on column A, row 1, and start entering in your X value data. So row 1, column A, what's my first number that I'm going to use? 1998 represents 8. 8, enter, 10, 12, 14, 16, 18. Now, if I were you, I honestly would pick it up and use my thumbs, just like you do whenever you text on your phone. Tend to be a lot faster whenever you do it like that. If you can't enter it like that, then leave it on the table and start entering like that too. It doesn't matter. Now, if I gave you 25 to 30 points, would you want to arrow up every time to get to the next point? Now, so what's it say to do there? Okay, so because we have 25
May I have your
points,
attention, please? This is just a reminder to Garraway seniors that the class senior
you hit
picture
Control 7,
will
it's
be
going to bring it
filed
all the way back up to
at
the top of
Garraway
the
High
data.
School at 7:30
Yeah.
a.m.
That's your
The bus
shortcut
will be
key.
held, and all students arrive
Now, go click on
Here at
cell
my career
B,
center.
row 1.
will need to sign in at the attendance office
Start entering your data
as
for
you
that.
arrive. Thank you.
2.65, 2.89, 3, 3.01, 3.2, 3.77. After you are done entering your data, please check it, because if your data is not entered incorrectly, you are not going to get the correct answer. Do we understand that, yes or no? Doing. Turn it back on. Okay, so what we're finding out is it's not the back. You're going to Unless you want to get a new one. Want to get a new one, you can. Gonna be a little bit behind though. Okay. So now, B is going to be your cost. Now, what I want you guys to always do is make sure that all of your data is entered in correctly. Because if it's not, you're not going to get the right regression model, which means if you don't have the right regression model, there's no point in doing it. So now we've entered in our data, so now what do I need to do? What's the next header on our steps? Make a scatter plot. So how do I make a scatter plot? Insert a new page by hitting Control-Dot. And what type of page am I going to use?
Statistics.
Data and statistics. Now look, yours is not going to look like mine. What I want you to envision is that where this board has Velcro on it, and you have a whole bunch of ping pong balls, and those ping pong balls represent the data, and those have Velcro on them, and then you stood up and you threw it up against the board, and what happened to the ping pong ball?
This is great.
It's stuck, right? Is everybody going to throw in exactly the same spot with exactly the same speed? No. So therefore, are they going to look exactly like mine? No. So what we have to do is now rearrange our ping pong balls so that they are appropriate and right. We get that. So we need to do that by simply clicking on the left and the bottom margins there. On the bottom margin, that's going to represent our x-axis. So what represents our x-axis? The cost of the year. The year. So click year and watch. Did you see the balls? They all moved. The ping pong balls just moved and they lined up according to the year. How many people in here think that's really cool, right? That's really cool, right? Okay, so now we moved it according to the year. But now what do I need to do? I need to move it according to the cost. So I'm going to click on the left-hand margin on the left-hand side, obviously. And what's that going to be? It's going to be cost, and watch the balls. They move. How sweet is that? That's really cool, right? It's like magic going on with your graphic calculator. Now, with that said, how do we go about finding if this has a positive or negative correlation? Well, how did we figure that out in our notes previously? We drew a line. So if we were drawing lines, we need to do the same exact thing here. Do you think your calculator will allow you to draw a line on this? Yes. If this is not on your lovely little notes page, you need to add it. So hit Menu, Analyze, and then what do you think we want to add? A movable line. Because how is it going to be helpful if we put a line in there and it does represent our data? So we want to add a movable line. Now, I want you all to pay attention. Are we looking up here? If you click on your line, do you see how I have my curved arrows? If your line does not turn into a curved arrow, keep moving down the line until it does. Okay? Okay, don't click on the balls, because if you click on the balls and you move them, it's not going to give, it's going to change your data. So do not click on the data there. You want to click on the line. Do we all understand that? Okay? Now, after you get the curved arrows, I actually want you to move this line so that you can get it where you think it's going to best fit. Notice I moved the top of my line, and now I'm going to come down here to the bottom, and I'm going to move the bottom of the line. Do we see that? Yes or no? Check with your partner, please, and make sure your partner and you are both at the same spot. Now, I want you guys to move this to where you think it is going to represent the best model for all of the data together. Be sure not to move by selecting any of the data points. Don't move your points, because if you move your points, you're changing your data. No, you do not have to have the same numbers, because maybe you think that that slope is going to be a little different than what my slope is. Okay? Now I want you guys to look at this thing. When you look at all this data, is there one data point that you think kind of is out there? The top one at the top right-hand corner. We call that an outlying point. It skews the data, doesn't it? It changes the slope. Okay, for those of you who have curved tests, how many of you have tests where the instructor will curve your assignment or your test based upon the highest score? Those are the people you don't like that change that score, so you don't get as many points for your curving. Do you understand that? Okay? Now, what we want to do is we want to come up with a trend line. Well, what's a trend line, Mrs. Yoder? Please write this down. You do not have this in your notes. I added it afterwards. A trend line is a line in the form of y equals mx plus b that was made by choosing 2 points from the data you feel best represents the data. What in the world does this mean? This means that Garrett may choose 2 different points than what Zach chooses, than what Camille chooses. Okay? Even though they choose different points, are they going to have the same type of regression line? No, they won't, because the points are different. And anytime you take 2 points and choose 2 different points to make an equation line, your slope and your y-intercept are going to be different. Now, is anything that I'm teaching at this point on your homework tonight?
Yes.
No. The only thing that's on your homework tonight is going to be graphing and making a scatter plot and then telling me the correlation, right? The trend line that will not be on tonight's homework, this will be tomorrow's. Okay? Now, with this said, I need you guys to look at your movable line that you picked. Does everybody have a movable line? Now, I want you to figure out, based upon your movable line, what 2 points does it hit clearly the most?
First.
Please tell me the x-coordinates of them.
8, 16.
8 and 16. How many people chose 8 and 16 and they went through those the most? Anybody else choose something else?
12 and 18.
8 and 12. How many people chose 8 and 12? Okay, it's about equal. I'm not going to lie. It seems like 8 and 12 seems to be the winner of the day. Okay? So what we're going to do, get out a sheet of paper, folks, or write on the back of it, whatever you want. What we're going to do is we're going to find the trend line. We have the point 8, 2.65, and also the point 12, 3. Meaning, in the year 1998, the cost of the gallon of milk was $2.65. And then in 2012, the cost per gallon of milk was going to be $3. Correct? That's what that information means up there. Okay, 8 corresponds to 1998. 12 corresponds to 2002. Everybody good on that? Now we have to come up with the trend line. To come up with the trend line, we have to first come up with a slope. So what's my slope going to be? That is going to be equal to y2 minus y1 over x2 minus x1. To give you 3 minus 2.65 is equal to 12 minus 8. Now, you can use your graphic calculators on this, and you can simply hit your calculator key up here, your scratch pad, hit Control Division key, and type in 3 minus 2.65, arrow down, 12 minus 8, and hit Enter. And what's your slope going to be? 0.0875. This is the slope. Do you notice how it calculated the whole entire thing for you? Okay, isn't that a beautiful thing? So I come over here and I actually write this down. That's going to be 0.0875. That's my slope. So now I have my slope, and what do I need to do? I'm sorry? I found the slope, so what do I need to find? I need the y-intercept. So which point am I going to choose?
The second one. Or maybe.
I would choose the second one because it's what? It's whole numbers. Okay, now which method are we going to use? Y is 3, 12 is, sorry, M is 0.0875, X is 12 plus B. And you're going to solve this thing for B. So if I come over here, watch, I can actually say times 12 and hit enter because it's going to take that answer that I previously had. And it already has it trapped in its memory, and it's going to give me a number of 1.05. If I solve for B, what do I do? And I have 1.95 is equal to my B. So now what's my equation? Y is equal to 0.0875x plus 1.95. Now, for those of you whose movable line went through the points 8 and 12 best, does your equation match pretty well to this equation right here? Well, those are what I use too. I think mine probably was a better match to that too, but look at mine. It's off tremendously. Why is it off tremendously? Because it's not hitting them exactly on 8 and exactly on 12. It's just hitting the bottom of 12. So the bottom of 12 would be like 11.9 or 11.5, right? So it's hard to determine that. Now, tomorrow when you guys come in here, we will talk about the rest of this. Today's homework is this worksheet. This worksheet is 4 problems. It should take you no time at all. It's literally make a scatter plot, plot these. We're talking like 15, 20 minutes max. I expect it to be done tomorrow so that we can use it in class the next day.
Not like, you know, they're my worst thing.